I'm Anusha Agnor from PQI, and you're watching a PQI Profiles, a show in which we get to know our members. So today I'm joined by Scott Crawford from Chemistry Department at Pitt. He is a fifth-year Ph.D. student working with Professor Jill Millstone in the area of nanoparticles. So Scott, welcome to our program.
Thank you so much for having me.
So firstly, congratulations on winning the PQI Poster Award at Science in 2017. So how do you feel about it?
Great, it's a tremendous opportunity. I mean, me and my colleagues in Jill's group have had a nice track record of success through PQI, so it's a wonderful opportunity to present the research we've been doing, and it's also a great opportunity for us to get funding and kind of promote the group and promote quantum science in Pittsburgh.
I'm glad to know that. So Scott, tell us about yourself, about your family, and a bit more about your background. We would like to know more about yourself.
Sure, well, it's probably the most boring one out of anyone who's going to be coming in here, because I was actually born in Allegheny General Hospital here in Pittsburgh, and grew up just outside the Pittsburgh airport over in Beaver County. Went to undergrad at Pittsburgh and still in Pittsburgh.
Okay, so you've spent a lot of your time here in Pittsburgh.
Yep.
So would you like to talk about your high school and more about undergrad experience at Pitt?
Sure, yeah, it's kind of interesting because I really wasn't very interested in the sciences growing up. That was something that kind of came on halfway through high school. I had a chemistry teacher named Jen Sattler, and originally I was taking the class to fulfill an elective, and I took Chemistry 1, and I thought, you know what? I have to take these science electives anyway. I laid the foundation. I'm going to keep on moving through chemistry and see if I can develop an appreciation for it. And when I decided to go to Pitt, I actually had a lot of credits transfer in, which enabled me to double major. But the entire time, my main interest was actually kind of on the social science side of things. I was interested in international relations, economics.
Okay.
But kind of on a whim, I decided to do a dual major in economics and chemistry. And I'll tell you what, I think God was leading me towards the sciences, because halfway through my undergrad career, I thought, you know what? This economic stuff, I kind of like it, but chemistry, man, this is really exciting. This is really cool stuff. And so I decided to go to graduate school for it, and I haven't looked back since.
So you did your undergrad in chemistry as well, right?
Yes, although my research was in Dr. Valenkar's lab in chemical engineering.
Okay. So can you talk more about your research and what's the prime motivation? I know chemistry always interested you, but is there anything else what motivated you to take up this nanoparticles research that you're currently doing?
Again, I think it was part of God's plan, because I didn't know what a nanoparticle was. I was interested in analytical chemistry. Wasn't planning on staying in Pittsburgh. I had some other offers from really good chemistry programs. But when I went on the visitations, the research was great everywhere. And then when I had the chance to meet Professor Millstone at Pitt, she said, well, when you think about nanomaterials, you can think about the periodic table being in 3 dimensions. And I didn't really know what she meant by that, but at the time I was like, man, this is really cool. And I decided to go to Pitt, and Professor Millstone reached out to me, and she said, you should really think about doing some research in our group. And so kind of as time wore on, I knew that nanoparticles were considered a cutting-edge technology, so I was kind of eager to get on sort of the cutting edge of materials research, but still didn't really know what I was getting into at the time. But over the last 5 years, I've really started to enjoy working in the lab and enjoy studying things that are on the order of, a virus. I mean, we're talking about something that's 1/500th, 1/1000th the diameter of a human hair.
Nanoscience. Yeah, I was always interested in nanoscience and nanoparticles back in my undergrad and grad school too. So what are the major applications of your research? I'm sure you're working on gold nanoparticles towards energy transfer applications. Are there any specific applications that you would like to talk about?
Sure. First of all, I should say we typically in the Millstone group, we do very fundamental research. So we're not as geared on the applications end of things. What makes a nanomaterial so exciting? If you think about, say, the metal on my watch here, if I want to change the chemical and physical properties of that metal, looking at a bulk material, there's not really much I can do. Most of the metals here are inside the watch. The atoms, very few atoms are actually on the surface exposed to the outside environment. So if I want to change the behavior of this metal, all I can really do is change its composition, melt it, mix it with another metal, form an alloy. But if you take it down to the nanoscale, and now we're talking about something that's the size of a virus, by definition, most of the atoms are on the surface of the particle. And so you can change not only now your particle composition, but also your particle size, your particle shape, even the surface chemistry of your material. So now instead of a bulk material where you have one handle to control your properties, at the nanoscale we have 4. So the biggest challenge, though, is trying to understand how each variable relates to our metal properties. So for me, I use photoluminescence as kind of that tool, right? So I can change one variable, like surface chemistry, and I can see how photoluminescence changes. And so if the intensity changes or the emission energy changes, I know that variable is controlling the electronic structure, and that I can then kind of exploit those structural variables towards specific applications. So I know that's a long intro to your question, but so really when we think about photoluminescence, we're thinking about a way to probe fundamental electronic structure of our particles. That being said, there actually are some really cool applications for especially near-infrared emitting particles. So the particles I work with emit in the near-infrared. The downside is they're not pretty colors. We can't see them with our eyes. So they're not like these quantum dot TVs, for example. But there's actually some really cool niche applications. One kind of, if I may, one cheesy demonstration I like to do. If I take a white light source, like a flashlight,
Right.
and I put it up to my finger, you'll notice that everything is absorbed by my skin except for the red light.
Yeah, it's emitted.
So with these near-infrared emitting particles, I think the most exciting application would be for something like biological imaging. You inject the nanoparticles into yourself, the nanoparticles will get taken up by a tumor.
Okay.
You can excite the nanoparticles, near-infrared light comes out, and then you can diagnose where the tumor is located. Some other applications we're excited about, things like chemical sensing. So you can look at how your emission energy or your emission intensity changes in the presence of certain analytes. So these particles have been used for things like heavy metal detection in drinking water samples. And then finally, the telecommunications industry relies on optical fibers to transmit information in the form of light over long distances. And it turns out it's actually most efficient when you're transmitting near-infrared light. So I think when you think about big picture applications, those are some areas that we're looking towards.
I think that's really interesting. So as a chemical engineer, most of my research was in basic science, and we delved a lot into analytical techniques. And you spoke about analytical chemistry, right? So what techniques do you use for your research?
It's a great question, because I think that's one of the cool things about nanomaterials and even quantum science in general is that, even though it's more material science research, it kind of encompasses a broad, it encompasses engineering, physical chemistry, physics, even sometimes biological processes. So the techniques that we typically use, I do a lot of fluorescence spectroscopy, obviously, both time resolved and steady state. We actually use a lot of X-ray techniques, so things like X-ray photoelectron spectroscopy. XRD. My particles actually are a little too small for that, surprisingly. The signal's a little too broad, but my colleagues all do. Obviously a lot of transmission electron microscopy, sometimes even SEM as well, inductively coupled plasma mass spectroscopy, and even more traditional organic techniques. We actually, the Millstone group in particular, uses a lot of nuclear magnetic resonance spectroscopy to measure the things like ligand densities and things like that.
Okay, I think that's a lot of techniques that you use. So do you consider yourself as a theoretical chemist or experimental chemist?
Definitely experimental, which is kind of why it's always interesting when I go to PQI meetings, because people have a really strong background in physics, for example, and so they'll ask questions about nanoparticle work functions and things like that, which I actually don't have as good of a handle for. So I actually definitely am more of a experimentalist. I really enjoy making something new and characterizing it.
So what's the most exciting and rewarding thing about your research? What interests you a lot about your research?
It depends on the day. That's a tough question.
Depends upon your mood?
Yeah, definitely on my mood.
Okay, mood swings.
But I think, just the other day I was trying to make nanoparticles embedded in metal organic frameworks, thinking about some applications for sensing, trying to see how metal organic frameworks might change the luminescent properties of these particles. So just a kind of what we call a Friday afternoon experiment in our labs, where we just get an idea and we try it, right? And then I got to go down to the electron microscope and actually image these particles and see these particles surrounded by metal organic frameworks, and it's just such an exciting feeling to realize you're making something new, you're seeing something new, you're seeing new properties. When you go on the microscope and you realize you're looking at something, that's so tiny that you're actually seeing individual planes of atoms, I think that's the most exciting part.
Okay, that sounds interesting. So, I mean, you're a fifth-year PhD student. I'm sure you would have had a roller coaster ride for all the 5 years doing the research, and I'm sure you would have encountered some great challenges. But are there any specific challenges that you would like to talk about?
Yeah, I mean, I think the initial challenge I faced, like I said, was I think a lot of undergraduate curriculums don't really cover nanoscience in very great detail.
Right.
So for me, it was kind of trying to relearn everything I thought I knew about chemistry. So it was kind of a pretty steep learning curve early on. Beyond that, just trying to, especially when you first start off, I think trying to find a project that interests you, that interests your PI, that interests the broader scientific community is a challenge. So my first 2 years of research was really just trying to find a research topic. It takes time, but then, once I did, I didn't look back, and here I am 5 years later.
Yeah, so was it a difficult escalation for you, not knowing anything about nanoscience in your undergrad, and then all of a sudden delving into nanoscience research in PhD? How was it like?
It was definitely a challenge. It took me a while, too, to really appreciate kind of what makes a nanoscale exciting. Like I said, when I first met with my boss, Professor Millstone, she was, as always, was extremely enthusiastic talking about the periodic table in 3D. But it wasn't until I started actually making the materials and as I started conducting my own independent research, but also presenting that research and trying to think about ways to make that information accessible, that I actually myself began to understand and appreciate what makes the nanoscale such a beautiful thing. But early on, it was definitely challenging.
Okay. So you're basically localite in Pittsburgh, right?
Yes.
So what do you think of Pittsburgh, like lifestyle, and is there anything that you would like to tell people who are new to Pittsburgh?
Sure. I mean, I think one of the nice things about Pittsburgh is that, at least for me, I mean, growing up in rural Beaver County, Pittsburgh's nice because it's definitely, to me, seems like a big city, but compared to, say, New York, Boston, Los Angeles, it's a lot smaller. But it's nice because you get a lot of city amenities, but you also have some space. I live in West Mifflin, right by Kennywood, so actually I have a big enough yard where I can do some gardening and things like that. So I don't feel like I'm quite in the city.
Okay.
But if I want to get whatever kind of restaurant or food I'm interested in, I can just drive 10 minutes or take a 20-minute bus ride and get whatever food I want. It's also great because it's really inexpensive. You can get a pitcher of beer for $6, right? It's hard to find that in many other cities.
I'm not sure of that. So you've spent a lot of time here at Pitt, right? So how would you summarize your experience at Pitt, like both your undergrad and grad experience? So is it like 9 years at Pitt?
Just about, yeah.
9 years,
I think 9 years come
right?
August, yeah.
So how would you summarize your experience at Pitt?
It's been great. It's like I said, I like the city a lot, but I think the best thing for me is that I'm very close to my family. I'm the youngest of 4 brothers, so I'm close to all of them. I'm very close to my parents. I have 9 nieces and nephews, and the great thing is I've been able to conduct research at a world-renowned institution. And at the same time, I'm a 20-minute drive from home, so I've been able to go to my niece's graduation, go to my niece and nephew's school plays, softball games, or what have you. So it's just been really great, been really rewarding to be able to do research at a top-notch institution, while also, having all the amenities of home very accessible to me.
So it looks like you're pretty much comfortable in Pittsburgh.
Very comfortable.
So Scott, I'm sure everybody does have an inspiration while growing up, right? Like, even if you want to go to grad school or pursue something, there is always an inspiration. So do you have any role models while growing up?
Yeah, I mean, for me, I'm a Christian, and that's something that's always kind of driven me to just in general try to be the best person I can be. Whether it's the way I treat other people, whether it's just trying to kind of use my God-given resources to the best of my ability.
Okay.
So for me, that's kind of just what drove me to whatever I would, whether it's making chicken when I work at Chick-fil-A, whether it's taking classes, whether it's when I, unsuccessfully tried to play baseball in high school. I've always tried to be as good as I could be and maximize my potential. And I think that's that's something that definitely drove me to the sciences. As far as kind of the people around me, I mean, Professor Millstone has been a great inspiration, just the way she presents her research, her passion for the field, kind of just, it's been really special too because she's a fairly young professor, so I'm one of her first graduate students.
Oh,
so kind of
wow.
watching her build the lab up has been really exciting.
Okay.
And beyond that, I'm also inspired by my coworkers. I mean, I'm very fortunate to have some wonderful people. I think some of them you'll actually be interviewing in the coming weeks. And just working with them each and every day inspires me to be a better
Right.
scientist, just learning from them, trying to teach them. So they're all my role models as well.
Wow, that's really amazing. So I know being a grad student, you don't get much time for recreational activities, but what are your hobbies? Like, what do you do in your spare time?
Yeah, actually recently I've taken up a lot of gardening. So anytime I eat like a piece of fruit, whether it's a mango or a tomato or something, I save the seeds. So I've got a bunch of
Okay.
these like avocado trees growing in my house. I like to read a lot. So one nice thing about being a Pitt student is you get free bus fare. So on the bus,
Right.
I'm just trying to read different books. I also like athletics. I know I don't look like it,
Uh-huh.
but in my spare time, I like to try just recreational boxing, things like that. I have a little punching bag in my basement,
Okay.
and like I said, I live across from Kennywood. So if anyone's ever in the West Mifflin area or
The
coming to
theme
Pittsburgh,
park.
yeah, it's a lot of fun.
Okay, I think that's really good. So you're a chemist, right? Basically, like 5 years into PhD. So what are your long-term goals, and where do you see yourself few years down the line? As in, like, would you like to continue into academia, or would you like to escalate into industries? So what's your plan, basically?
Yeah, that's a great question because I think I've been very lucky in that as an undergraduate, I actually got to do research at Lanxess Corporation over in Robinson.
Okay.
So I had some industrial experience there, and I really enjoyed that. This past summer, I worked through the Mickey Leyland Energy Fellowship at the
Wow.
National Energy Technology Lab down in South Park, and I'll be working for them a little bit in the coming months. So
Okay.
I've had some experience in government lab. I really like that, and of course, primarily as a grad student, I've been doing academic research, and so there's things about all three that I like and things that I don't like. Right now, I'm definitely a lot more open to academia than I think I was when I first started graduate school. So I think I'm definitely interested in trying to maybe pursue that. 'Cause I like the opportunity to be creative and to kind of direct your own research, the opportunities to chase down things that interest you. So, but I'm flexible though. My options are open to all three avenues. But I think I'm definitely starting to strongly consider academia as a career.
So when you say academia, is it like becoming a postdoc, or would you eventually see yourself becoming a professor?
I think that would be the ultimate goal. Yeah, as a
Okay.
professor at a research university.
Okay.
I think I'd like to start to try to design materials, kind of building off the research I'm doing now, try and design some functional materials, but maybe more applications-oriented research. So looking at things like designing luminescent sensors, luminescent medical devices, things like that,
Okay.
and trying to optimize their properties.
I think that's fantastic. So, can you describe me your experience with PQI, and for how long have you been associated with PQI?
So the first time I became familiar with PQI, I want to say it was in fall of 2015. So I just got my first paper out.
Okay.
And my boss said, hey, there's this conference coming up on Pitt's campus called Science 2015. I want you to present a poster. And then, so it kind of was on my radar then. And then I heard about PQI 2016. I said, hey, Professor Millstone, do you mind if I presented this? And, from there it's been great. So I got to meet Ode, who used to, I guess she was the
Right,
executive director.
Yeah, she was the executive director.
So I got to know her and some of the other staff members back then, and then just over the past couple years going to the PQI event and the science events, and then also going to some of the organized talks. I've really developed a good relationship with the Pittsburgh Quantum Institute, and I know my coworkers would say the same thing too. And so we just actually had the chemistry department just had a recruiting weekend, and I was talking up every student would come in. I say, hey, if you're interested at all in
Right.
physical science or nanoscience, definitely check out PQI because
Okay.
great opportunities.
I think that's very nice of you to do. So lastly, would you like to give any advice to students, firstly, who would like to, who are applying for poster awards, and who would like to associate with PQI in the future?
Yeah, if you have the opportunity to do so, I definitely recommend it. I think, I won the poster award in the fall, but, before that, I presented 3 times, didn't get an
Okay.
award, but it was still a wonderful experience. As you get to know more people in PQI, you also become more familiar with other events on campus. So things like recently there was a American Vacuum Society meeting, and the only reason I knew
Right.
about it was because of PQI, and so I got to participate in that, and actually won an award there. So I think for students who are interested, if you're thinking about doing a poster, definitely try for it. When you're presenting your poster, I think just try to be as concise as possible. Try to make it accessible. 'Cause, one
Okay.
challenge is that, as I said, for me, I don't consider myself a theoretician, but of course a lot of people in PQI are theoreticians. So, just try to keep in mind that your audience might have a different way of looking at things than you, and so you want to try to make it as accessible to as broad of an audience as possible.
Thank you, Scott, for being on our program.
My pleasure.
And we are very glad to have you here today. It has been PQI Profiles, and thank you so much for watching.